Hi everybody, so this is a continuation of our note on transforming sinusoidal functions. So that means sine or cosine functions. So we already learned what all of the parameters do and how they affect the curve. So now we're going to put that all together and graph some more complicated sinusoidal functions. So here's kind of a method, one method of how to graph, okay? There's two ways that you can do it. It kind of depends on your level of comfort with the topic matter. If I wanted, I could just graph it all in one graph. I wouldn't have to show the stages of the transformations. Some of you will be able to do that relatively quickly. Some of you will need to show all the steps to ensure that you're getting the right answer. It really is a matter of your comfort level. I won't be marking you any harder if you do it one way or the other. I really just look at your final curve and see if it's correct or not. The only benefit of doing it in stages is then maybe I can give you part marks if one of your stages is correct. So that's kind of a personal decision you're going to have to make. The first thing you always do though is find the period, okay? The period is always 360 degrees divided by the k value that they give you. So you want to work the 5 key points around the period. So remember, if you have a sine curve, you always just start on your axis, go to your max, go back to your axis, go to your min, and then go back to your axis, okay? So the axis will start at 0 and will end however long your period is. So if your period is 120 degrees, you want to take 120, you want to start at 0 and end at 120. And then halfway through you'll have another axis point, so we're at 60. And then halfway between those two axis points, at 30 you'll have a max, and then halfway between 60 and 120 at 90 you'll have a min, okay? So you want to divide the period by 4 to find out how far apart the points should be. So if your period is again 120 divided by 4 is 30, so you would have 0, 30, 60, 90, 120. So you'll be able to plot all 5 of your points within those 4 spots. So don't just go start labeling all your tick marks before you think about what the period is and how much you need to show, okay? Did I ask you to graph 1 cycle, 2 cycles? If I didn't tell you how many cycles, then what do you think is most useful? Okay, you need to do some analysis before you actually start graphing. Okay, so once that's done, you always have to start with any stretches, compressions, or reflections, and then your translation. So the order here doesn't really matter. So another way of doing this, and this is kind of my preferred method here, is by starting with kind of together the axis and the period. So you know what the axis is just by looking at the function, because it's just equal to the c value or the constant at the end of the function. So it's not within the argument, it's outside the argument added on. If nothing's added on, then your axis is 0. And you're good to go, okay? So you draw a dotted line for your axis, kind of like you would for an asymptote, right? And you put y equals whatever c is, 3, let's say. Then you find your period and divide your points by 4, and you put them on the dotted line now, though, okay? So you have 1 on your axis at the beginning, 1 on your axis at the end, and 1 on your axis halfway between those two. Then you plot the max based on your amplitude. So if your amplitude is 5, you just go 5 points up from the axis to do your max, and that's halfway between the first 2 points. And then you do your min by going down whatever the amplitude is, halfway between your second 2 axis points. So then you have already applied A, K, and C. So you have this nice curve, you draw it. Once that happens, then you just shift that curve, left or right, depending on D. So I actually apply A, K, and C all at one time, and then just shift left or right and do D. So that's probably the way I'll be modeling for the most part. Okay, so we have 5 examples. So it's best to get some graph paper and set up your, let's see, this is quite blown up. Set up your axes so you're ready to go, okay? So this is -3 sine 2x. I feel like I picked the wrong one as the first one. No, we're good. So let's do a little bit of analysis first. So the axis is y equals 0. Okay, because there's nothing added or subtracted at the end here. So it's still just 0. The amplitude is 3. So that means that the max is 3 and the min is negative 3. Okay, because you're going up 3 from 0 to get to your max and down 3 from 0 to get to your min. Okay, the period is 360 divided by k, so that is divided by 2. So a period here is only 180 degrees. All right, so that means I'm going 180 divided by 4 is 45. So my points will be 45 apart, degrees apart. So 0, 45, 90, 135, 180. I also have a vertical reflection. So that means my pattern, instead of going up, will be going down, then middle, then up, then middle. So I normally go middle, up, middle, down, middle, but because it's reflected, I'm going middle, down, middle, up, middle. Okay? So now that my analysis is done, I can start actually graphing. So I'm going to label my axis, even though it's just where the x-axis is. I'm still going to put a dotted line. You might not really be able to see it on yours, but at least label it, y equals 0. Okay, and there you go. So all of your points are going to start on the axis. And then I'm going to divide. I know that one period is 180 degrees. So I'm going to do 45, because 180 divided by 4 is 45. So 45, 90, 135, 180. Or did I tell you? Just a second. Okay, so I'm just graphing one cycle. Okay, if you want to graph 2 cycles, you can, then you would just go up to 360. So I know that I always start on my axis, I always end on my axis, and then halfway in between, I'm also on the axis. This is only for sine functions, not cosine. Cosine, you would have to do it differently. Okay, so this is only if it's sine. Now, I know halfway in between my first 2 axis points is my maximum. So at 45 is going to be my maximum, which in this case I determined was 3. So this is 3 here. Now halfway between my my second 2 axis points will be my minimum, which we determined was negative 3. So there you go. And you label it with the function. Okay? And that's it. There's no phase shift and there's no vertical shift or anything like that. So I'm done. There's my curve. That's your first example. Okay. See if you can do the next example on your own. Use pencil. And then you can check back with my example here. Okay. So in this case, we have 2 sine of a half x. So our axis is still y equals 0. We haven't actually gone up or down at all. And our amplitude is 2. So that means between those 2 pieces of information, my max is 2 and my min is negative 2, right? Because I'm going up 2 from my axis, down 2 from my axis. My period is 360 divided by a half, so that's 360 by 2, which is 720 degrees. I divide that by 4, which is 180, so I need my ticks to be 180 degrees apart to accurately show this transformation. Okay, to show the 4 sections. All right. So, here's 180, 360, 540, and 720. Okay, it's a sinusoidal function, so I start on my axis, I end on my axis. Halfway in between, I'm at my axis again. Between the first two axes points, I go to my maximum, which is 2. Between the last and second pair, I go to my minimum, which is -2. And there you have it. That's it. There's your curve. You label it. Okay? If you wanted to draw another cycle, if I said 2 cycles, then you just keep going. Add another 180, you'd have another maximum. Go another 180, you'd have another axis point, etc. You just continue with the curve. Okay. So now we're going to get into a bit more shifts and everything like that. Shifty. Okay. So notice here you have a k value and a d value, so you have to factor out your k value to accurately show your d value. So let's take a look at the axis. First of all, is y equals 1, okay, because our c value is 1. Our amplitude is 3, okay, the amplitude is 3. So that means my maximum is 1 plus 3, which is 4. And my minimum is 1 minus 3, so my axis down 3, which is -2. Okay? My period is 360 divided by a half, so that's 720. And then I'm going to go right 60 degrees. Okay, so I have to think about this because I want enough space so that I can show right 60 degrees easily. So if I went up by 45s, for instance, it's kind of hard to guess where is 60 between 45 and 90. So if I increase by, let's say, 60s, then that would just mean when I move it right 60, I only have to move everything over 1 square. But we have to see if we have enough space to get up to 720 if each tick mark is worth 60. So, 720 divided by 60, I would need 12 tick marks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I'm just short 1, so we'll just pretend there's another one here and create 12. Okay, so this is the type of critical thinking that we expect at this level of math, that you're not just randomly picking what your tick marks are, you're being really conscious about how you're going to have to move the graph as you go. Okay, so let's go ahead and actually graph this thing. So the first thing you want to do is put a dotted horizontal line at y equals 1. Just show your axis, okay? So here's your axis. Boop, 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 boop. Oh, you should use a ruler. You should use a ruler. I don't have one that long. So there's your axis. Okay, I'm expecting you to use a ruler. Okay, now, this is a sine function that has a period of 720. We decided we want one of these to go up by 60. So this would be 60, 120, 180. Okay, why am I labeling 180 and not 60 and 120? Because 720 divided by 4 is 180, so that's where my maximum is going to be. That's what I want labeled. Okay, so I go another 3, so this will be 360. Another 3, this would be 540. And another 3, again, we're creating one here to be 720. Okay, so tick mark. Okay, so now I am graphing a sinusoidal function. So a sinusoidal function starts on its axis. So now the axis is here at 1. So I start on my axis, okay? Not on the x-axis, but on the axis of the function. I also end on the axis of the function. And halfway between those two, I'm on the axis of my function. Okay? Halfway between the first two axis points is my maximum, which we determined was 4. So 1, 2, 3, 4. Or because the amplitude is 3, you can just count 3 up from your axis. Okay? Halfway between here is my minimum, so at -2. So here we go. We're not done yet though, because we haven't applied the phase shift. So this would be the graph which includes the a value. So this is the graph of y equals 3 sine 1/2 x plus 1. Okay, we don't have the 60 in there yet. So now this isn't too bad because we literally just take each point and shift it over by 60. And because we had the foresight to make 60 just equal to 1 grid point, we just have to move everything to the right by 1 grid point, which is the equivalent of moving it by 60. Okay, so here we go. This is our final curve. Okay, now often you'll be asked to label the coordinates. So this coordinate would be 60, 1. This coordinate would be 180 plus 60, so 240, 4. This coordinate would be 420, 1. This coordinate would be 600, -2. And this coordinate would be 780, 1. Okay? And you can check if you're right by putting any of these degrees, the value of the degrees, into the function and making sure that the y value comes out as it should. So when you put 240 degrees into the function, it should spit out 4. So that's a good way to test and show you're reflecting, okay, which is something that you're assessed and evaluated on, is to demonstrate a sense of reflecting in your work. Okay, we have 2 more. Notice that the next one is a cosine function, so things will shift a bit, literally. Gotta love those math jokes, right? Okay. So here we go. We have -2 cos 3x plus 135 minus 1. We have to factor out the k to give us this. So 135 divided by 3 is 45. And sorry, that should be a plus. That's my bad there. Okay. There you go. So let's take some time to analyze this before we start graphing. So our axis is -1. Okay, our amplitude is a equal 2. Okay, the amplitude's not -2, it's +2. It's just the absolute value of a. So that means our max is -1 plus 2, so it's 1. And our min is -1 minus 2, so it's -3. Okay? Our period is 360 divided by 3, which is 120 degrees. Okay, so an entire cycle happens at 120 degrees. Okay, then we're going left 45 degrees. Okay, also notice that we have a negative a value, so we're going to be, it's a negative cosine function. You got to think of that. So a normal cosine function will go top, middle, bottom, middle, top. But a negative cos, everything's flipped, so it'll go bottom, middle, top, middle, bottom. So when we're sketching that, we're starting at our minimum, going up to our axis, further up to our maximum, down to our axis, and further down to the minimum. And that's what will happen in one cycle. So make sure you understand all of this, and now we're just going to apply it to the actual graphing. Okay, so first we'll sketch our axis with a ruler, right guys? At -1. Okay, now our period is 120 degrees, and we're also going to need to be shifting to the left 45 degrees. So 120 divided by 4 is 30. So I'm still going to make, what am I going to do here? I'm going to make every 2 ticks 30, because 45 is just 1.5 of 30, and moving over 1.5, you can make a pretty good case for where 1.5 is in a tick. It's when you have to do like 0.47 or even a third gets a little bit dicey, but 1.5 grid squares is fine. So I'm going to say that this is 30, so this is 60, this is 90, and this is 120. So I actually have lots of space here, so I'm going to graph 2 cycles just to show you an example of graphing 2 cycles. So then another 30 would be 150, so then 180, 210, sorry, what am I thinking here? Yeah, 210 and then 240. Okay? So, we're going to start on our axis. No, we're not. It's a cosine function. It's a negative cosine function. So in a negative cosine function, you start on your minimum. Okay? Now, my axis is -1, and my amplitude is 2, so I'm starting at my minimum of -3. Okay? I'm starting at a minimum because it's a negative cosine function. So instead of starting at a max, we're reflecting it and starting at a minimum. Then we're going up to the axis, and then that means we're also ending on a minimum because we're completing our cycle. So our end at the whole period is 120. So we start and end on a minimum. Now what happens halfway in between those two? Think about it. What happens halfway in between the minimum and the maximum? Sorry, the minimum and the minimum. Halfway between is the maximum. Okay? So we go to our maximum, which is the axis plus 2. So at 1. Then halfway between the min and the max, we're on our axis. And again, halfway between the max and the min, we're on the axis. Okay, so this pattern repeats in the next 120 degrees. So start on a min, end on a min. Halfway between, we're at a max. Then halfway in between each of those, we're on the axis again. So the pattern repeats. Sorry, that should be more direct here. There we go. Okay, so we've already applied A, the amplitude. Everything's stretched up by 2. We've applied the axis. Everything's moved down 1. And we've applied the period, or the K value. Everything's squished in by a third. Okay, so now all we have to do is take this pink one and move it to the left 45 degrees. So each one of these squares I determined was 30, so 45 degrees then is 1.5 of them. So everything's just moving over to the left 45 degrees, which in this case is equivalent to 1.5